Okay, question number 21, as shown on the screen, it says, a ray of light is incident on mirror M1, and after reflection is incident on mirror M2 as shown in the diagram above. Calculate the angle of reflection of the ray at mirror M2. The diagram from the question was given as mirror 1 and mirror 2. We have something like this for the mirrors. This was mirror 1 and this mirror 2. The ray strikes mirror 1, reflects and reflects off again. Okay, and then the glancing angle between the ray and the mirror 1 was 30 degrees. Now quickly draw your normal. The angle of incidence should be 60 degrees. Remember from Snell's law, angle of incidence and reflection are equal. So here is also 60 degrees. And then from your alternate angles rule in mathematics, whatever angle you have here, you have same angle here. So here also 60 degrees. And then you draw a normal. Here should be 30. So the answer should be 30. So the angle of reflection at mirror 2 is 30 degrees. Number 22 says, a ray of light incident on a body X as shown on the diagram above. What is the refractive index of the body? Now quickly remember, this is air, and I'm going to give a very easy formula to apply. Refractive index of air sine the incidence equals the one for X sine the refraction. Okay, and the one for air is always 1. Okay, index for air is 1. So we have 1 times sine. Now the incident angle is the angle between the ray and the normal, not the boundary. So here should be 60 degrees. So we have sine 60 equals the 1 for X, and then we have sine. Now if here is 58, what should be here? Here should be around 22. So we have sine 22. So basically it means index for X should become sine 60 divided by sine 22. So let's solve that with a calculator. Hold on. We have sine 60 divided by sine. Sorry for that mistake. This angle is not 22. This angle is 32. Okay, that's my bad. 32 because 90 minus 50 gives you 32. So here should be 32 and here should be 32. So let's divide that again. So sine 60 divided by sine 32, and that should give you 1.63 as the index for X. Number 23, light travels in straight lines. In which of the following is the principle manifested? I, pinhole camera, II, formation of shadows, III, diffraction of light, IV, occurrence of an eclipse. All the answers are correct except diffraction. So the answer should be option B, I, II, and IV only. Number 24 says, the image of any real object formed by diverging lengths is always dashed. The answer is always erect. You either see erect or you see upright. Okay, so for a diverging length, the image formed is always erect or upright. That's the answer to that question. Number 25 says, which of the following is not self-luminous? A, incandescent fluorescent tube, B, the lighted candle, C, the moon, and D, incandescent electric bulb. The answer here is the moon. The moon is non-luminous. Number 26, an object is placed on the principal axis and at the center of curvature of a concave mirror. The image of the object formed by the mirror is dashed. Quickly, I'm going to give you a shortcut for this guy. We have a concave mirror of this nature. Okay, so this line is your principal axis. Okay, and here is the center of the circle. Here is center of the curvature. Okay, this is the pole. We have the focal point. I'm going to label this. I call here 1. I call here 2. Call here 3. Call here 4. Call here 5. Call here 6. And I call here 0. This is the back of the mirror. Now quickly, I'll give you a formula to apply. Okay, the V is always equal to 6 minus U. Okay, or V plus U equals 6. Now to know the image position, I'm going to do 6 minus where the object lies. Now since the question says it lies at the center of curvature, and that is 3. So we're going to say the image should be 6 minus 3, and that is still 3. It means the image will also be formed at the center of curvature. So the answer should be option D. Number 27 says a wire stretched between 2 points 1 meter apart. If the speed of the wave generated on plucking the wire is 200 meters per second, what is the minimum frequency which will resonate the wire? Quickly recall that velocity equals to frequency times wavelength. We can say frequency becomes velocity over wavelength, and the V was given as 200, while the distance between the 2 points was given as 1 meter. So we have that. So the answer should also be 200 hertz. That's option C, 200 hertz. Number 28, 60 complete waves pass a particular point in 4 seconds. The distance between 3 successive troughs of the wave is 15 meters. Calculate the speed of the wave. Quickly, let's find the frequency. Okay, the frequency is number of oscillations in the time given. So we have 60 divided by 4. Okay, and this should be, let's see, 15. Yeah, so we have 15 hertz as the frequency. Now quickly, we were told that the distance between 3 successive troughs is 15 meters. Now 3 troughs gives you 2 wavelengths. Okay, so 2 wavelengths equals 15. So one wavelength should be 15 divided by 2, and which will be 7.5. But we're asked to find the velocity. So V is equal to F lambda. This should be 15 times 15 over 2, and this should be 225 over 2. Let's see what that will give us. That should give us 112.5 meters per second as the answer. Number 29. Which of the following media allows the transmission of sound wave through them? I air, I liquid, and I solid. Now sound travels through a medium, and all these are media, so basically all of them will work. The answer should be option C. That should be the answer. Number 30. Number 30 says, which of the following wave characteristics can be used to distinguish a transverse wave from a longitudinal wave? Now remember, only transverse waves can be polarized. So the answer to that question should be option B, polarization. Number 31, a sound note of frequency 250 Hz and wavelength 1.3 meters is produced near a hill. If the echo of the sound is received 1 second later at that point, how far away is the hill from the point? Quickly, let's find the velocity of the sound first. Recall again, V equals to F lambda. The frequency here was 250 and the wavelength was 1.3. Let's see what our V should be. Times 1.3, and that should be 325 meters per second. So we are asked to find the distance. For echo, velocity equals to 2 times the distance over time. The distance should be velocity times time divided by 2. This should be 325 times the time was given as 1 second over 2. That should be half of that guy. So over 2, the answer should be 162.5 meters, option C. Number 32, the period of a wave is 0.02 seconds. Find the wavelength if the speed is 330 meters per second. Now recall again, V equals to F lambda, but F, recall, can be 1 over period. So V can be lambda over period, and we are asked to find the wavelength, meaning the wavelength should be the velocity times the period. The velocity was given as 330 and the period was 0.02. So let's see what that gives us in the calculator. We have 330 times 0.02, and that should give us 6.6 meters per second as the answer. 33. An alternating voltage with frequency 50 Hz has a period of dash. It's very simple. The period is 1 over the frequency, and we have 1 over 50, and that should be, I think, 0.02 or thereabout. Let's see. Yeah, 0.02 seconds as the answer. Number 34. A listener can detect the instrument from which a note is being sounded because different instruments produce the same note with different. The answer should be quality, but it's not in the option. So the option that is there should be option D, overtones. Option D is the correct answer to that question. Number 35. What is the escape velocity of a body on the surface of the earth with radius r, give me everything. Don't forget that the formula for escape velocity v is square root of 2g or square root of 2 capital Gm over capital R. So any of these in the option should be correct, and that should be option 2 small g and small r is not there. 2Gm over R. Okay, the neglect energy losses. These options are wrong, okay? This answer is correct. The options were obviously wrong. Let's move on to number 36. A charge of 1.6 times 10 to the power minus 10 coulombs is placed in a uniform electric field of intensity 2 times 10 to the power 5 Newton per coulomb. What is the value of the force? Now recall for electric field, okay, that the electric field intensity is force over charge. So the force can be the field times the charge. So multiply the values given together. The field was 2 times 10 to the power 15 and the charge was 1.6 times 10 to the power minus 10. So this, let's see what that will give us. 2 times 10 to the power 15 times 1.6 times 10 to the power of negative 10, and that should give us 320,000. Yeah, so that's the answer, 320,000, and that should be option B. Number 37. A balloon containing 546 cm of air is heated from 0 to 10 degrees Celsius. If the pressure is kept constant, what's the volume at 10? Now, we are applying Charles' law. Recall V1 over T1 equals V2 over T2. The initial volume was 546. Temperature was 0. That's 273 Kelvin. We are finding the new volume at 10, and that will be 283 Kelvin. So quickly, let's solve this quickly. So we're going to say 546 divided by 273. Sorry, 546 divided by 273 times 283. And the answer should be V2 as 566 centimeter cube. Number 38. Calculate the inductance of the coil in the circuit shown. Quickly, let's find the inductive reactance first. Now recall that V can be equal to I times XL. So let's find XL. We have V and I. That will be V over I, and the V is 240 and the I is 2. So XL should be 120 ohms. Now quickly recall that XL equals 2 pi FL. So we have 120 equals 2 times pi. The frequency there was 100 over pi, then times L. Pi takes out pi, okay? 2 here 1, 2 into here becomes 60. So L should be 60 over 100, and this should be around 0.6 Henry as the answer. Number 39. Calculate the electric potential at a distance 20 cm from a charge of 0.015 placed in air. Now quickly, potential is basically kq over r. Our K is 9 times 10 raised to 9. The charge was given as 0.015, and then the distance was 20 cm. So 20 divided by 100 to convert to meters. Let's solve that quickly with our calculator. 9 times 10 to the power of 9 times 0.015 divided by 0.2, and that should give us 6.75 times 10 to the power of 6. Alright, let's count it. 1, 2, 3, 4, 5, 6. Power of 8. Okay, this should be the answer to the question. Question 40. A capacitor of capacitance 25 microfarad is attached to an AC power source of frequency 200 over pi hertz. Calculate the reactance. Now quickly recall that XC is 1 over 2 pi FC. So let's solve that. So we have to find XC. We have 1 over 2 times pi. The frequency was 200 over pi, and times the capacitance was 25 times 10 to the power of minus 6. So pi takes out pi. Let's solve. Let's work out the rest. So quickly, the bottom we have 2 times 200 times 25 Okay, we have this as a value times 10 to the power of minus 6 and then 1 over the answer, and that should give you 100 ohms. So the value is 100 ohms, option A.